Hi guys, we are going to be going over 6.5 now, which is adding and subtracting fractions again. So I'm going to flip it around here. All right, so it says Malia bought shell beads and glass beads to weave in a design in her baskets, and she bought 1/4 pound of shell beads and 3/8 pounds of glass beads. How many pounds of beads did she buy? So they want us to add this. Now it says to write it in simplest form. Again, that is not necessary. You may wish to do that, but I would just keep it by itself. So find a common denominator by multiplying the denominators. This is one way. So what you could do to find a common denominator, because you cannot add these fractions together because the denominators are not the same. So therefore, the quick method to do that is just simply multiply those denominators to find a common denominator. So 8 times 4 would be 32. So they're saying that is one way to do it. So to change this, we're going to change these to 32. So what would I have to do to 4 to get it to 32? I would have to do 4 times 8. So then I must do the same to the top, which is multiply by 8. 8 times 1 would be 8. Here, what would I do to 8 to get it to 32? I would times it by 4. So then I would do the same to the top. So 3 times 4 is 12. Now I can go ahead and add. If I add 8 plus 12 would be 20 over 32. And this is good enough for me for you to keep it like that. Here is the thing. You guys could have done the other way of finding the least common denominator. So if you found the least common denominator, you would have just done multiples. So here, look at the bigger one, which is 8. So we are going to go by 8s. Can I get a 4 to an 8? I sure can. So therefore, I'm going to change these all to 8s. And this one is already an 8th, so I'm just going to keep that the same. And then what would I do to a 4 to get it to an 8? I would times it by 2. So if I times this by 2, I must do the same to the top to make sure you are timesing it by 1. 2 times 1 is 2. So what is 2/8 plus 3/8? And remember, you can just add the top. So what is 3 plus 2 is 5 over 8. So your answer is 5/8. Now how you can check whether these are still the same is, what can I do to an 8 to get it to 32? Well, I would times it by 4, and I would times the top by 4. So therefore 4 times 5 is 20, which is what I had. So they are both the same, just one is reduced and the other one is not. So that is how you do that. All right, next. Here is they want you again to find a common denominator. So in this case, it says, when subtracting two fractions with unlike denominators, follow the same steps that you would follow when adding two fractions. However, instead of adding the fractions, you're just subtracting, which we've already talked about. So first we should find a common denominator. So I always look for the biggest one, which is 10. Then I can go and see, can I get my smaller one over to the bigger one? In this case, I can. So therefore, I am just sliding this one over because it's already in tenths, but now I can change this one to 10. What would I do to 5 to get it to 10? I should times it by 2, and then this one by 2. So this one, 2 times 2 would be 4 on top. So now I can subtract. Again, my denominator will stay the same. I had 9 slices, and then I had 9 slices left. I ate 4 of them. So how many do I have left now? I have 5 out of 10. And we could have kept that as our answer, and I would have accepted that. The other thing that you could have also done is you could have reduced it by using the factor rainbow. 5 could go into both 5 and 10. So therefore you could have reduced these by dividing both 5 on both the top and the bottom. How many 5s go into 5 would be 1. How many 5s go into 10 would be 2. So you could have also said a half. All right, so now I'm going to come down here. Same thing. We have to find a common denominator. And then don't worry about the simplest form. I'm not worried about that at all. So here we go. Here, can we add these? You should be saying no, because the denominators are not the same. So go at the bigger one, which is 12. Can I get a 3 to a 12? And this is where you should be saying yes. So therefore, I'm going to change these all to 12s. Well, this one is already in 12, so I'm just sliding this one on down. And now this one is in 12ths. What do I do to a 3 to get it to 12? I times it by 4 and this one by 4. So 4 times 1 is 4. So your answer would have been 9/12. And you could have kept that answer just like that. Now, for those of you who want to know how to do the simplest form, I'm just going to show one more of those today, and then I'm going to be done with showing the simplest form because I really don't want you to do it. You can do the factor rainbow of the top number, which is 1 and 9. And then what else could go in there would be 3. So can 9 go into 12 evenly? No, it cannot. But can 3 go into 12 evenly? Yes, it can. And can 3 go into 9 evenly? Yes, it can. So therefore, I can divide both of these by 3. How many 3s go into 9 would be 3. How many 3s can go into 12? That would be 4. So this is exactly the same thing, just a different way of saying it. All right, so now we're going to go on to the next one. Can I add these? You should be saying no, you cannot. So therefore, in order to do this, I would have to look at my bigger one, which is a 7. So you can go by 7s. So can I get a 5 to a 7? No, I cannot. So go by to the next 7. 7 times 2 is 14. Can I get a 5 to a 14? No, I cannot. So then 21. Can I get a 5 to 21? No, I cannot. So then 7 times 4 would be next, which is 28. Can I get a 5 to go into 28 evenly? No, I cannot again. So now I'm going to do 7 times 5, which is 35. Can I get a 5 to a 35? Yes, I can. So therefore, it took me a while, but I finally figured out a common denominator. It would be going to 35. All right, so what do I have to do to 5 to get it to 35? I have to times it by 7, and this one by 7. 7 times 2 is 14. What do I do to a 7 to get it to 35? Times that by 5, and this one by 5. So that would be 15 over 35. Now I can add them because they have common denominator, which is 35. So now what is 15 plus 14? 15 plus 14 would be a 9 and 2. So that would be 29/35. And that is good enough for me. Next, we have to find a common denominator again. So going by the largest number, which is 6s. So we're going to go in multiples of 6. Can I get a 4 into a 6? No, I cannot. So 6 times 2 is 12. Can I get a 4 into 12? And this is where it is a yes. So I can change these all to 12s. What do I do to a 6 to get it to 12? Times that by 2 and this one by 2. That would be 2 12s. What would I do to a 4 to get it to 12? Times that by 3 and this one by 3. That would be 9 12s. So therefore, 9 plus 2 is 11 over our same denominator, which is 12. So our answer is 11/12. Next, here, I cannot subtract because the denominators are not the same. So therefore, I have to find a common denominator. I'm going to look at the largest one, which is an 8. Can I get a 4 to an 8? I sure can. So therefore, I'm going to change these to 8s. And since this one is already an 8, I'm just going to bring that on down. So what can I do to a 4 to get it to an 8? And times it by 2, and this one by 2. 3 times 2 is 6. So what is 6 minus 1 is 5 over 8. So this is 5/8. All right, next, this one, I have to again find a common denominator. So I'm going to go by my biggest denominator, which is 7. I'm going to go in multiples of 7. So 7 times 2 is 14. We'll start right there. Can 4 go into 7 evenly? It cannot. Can 4 go into 14 evenly? No, that would not work either. So I got to keep on going. 7, 14, 7 plus another 7 would be 21. Can I get a 4 to a 21? No, I cannot. So then now I go plus another 7, which would be 28. Can I get a 4 to a 28? And yes, I can. So therefore, I just found a common denominator, which would be changing these to 28s. So 4 times what will give me 28? I should times this by 7 and this one by 7. That would be 7 over 28. What can I do to a 7 to get it to 28? I would times it by 4. All right, now remember this changed up the sign on us. It is subtraction, not addition. So 7 minus 4 is 3 over 28. That is your answer. All right, next. Here we go. Now, of course, you guys can do the quick method of just multiplying those two. That is another way to find a common denominator as well. So I just want you to know that. But here we go. If you did this one, you can go by multiples of 10. So 10 times 1 is 10. Can I get a 4 to a 10? I cannot. So now I'm going to go up by another 10, which is 20. Can I get a 4 to a 20? And this is where I can. So I'm going to change these all to 20ths. What do I do to a 10 to get it to 20? Times it by 2, and this one by 2. 9 times 2 is 18. Then what do I do to a 4 to get it to 20? Times it by 5, and times this one by 5. 5 times 1 is 5. Please make sure you're paying attention to the signs because they do switch it up on you. So what is 18 minus 5? 18 minus 5 is 13 over 20. So your answer is 13/20. All right, so I want you to do a couple on your own. I want you to try 9 and 12. So please pause the video and try those on your own. Okay, so you could have done one of two things. You could have changed this to 60ths, or you could have found the least common denominator by going by 10s, 10, 20, and 30. So 30 would have been your common denominator. So you could have changed these all to 30ths by timesing by 3, and by 3, that would have been 9. And then here you could have times by 5, and by 5, that would have been 5. So 5 plus 9 is 14/30. All right, this one, you could have gone by 7s. 3 cannot go into 7, so 14, that did not work. And then 21. 21 would have been your common denominator. So you would have times this one by 3 and this one by 3. That would have been 15. And then what would you do to 3 to get it to 21? Times it by 7 and this one by 7. That would have been 14 over 21. So then 15 minus 14 would have been 1 over 21. And that would have been your answer. All right. Now this one was slightly difficult. So I'm just going to talk about this very quickly. They are doing algebra. Now, a lot of people don't understand the way that they are trying to show it. So I am going to do a different way to see if you guys can understand a little better. So say, for example, I put in 5 minus blank equals, let's say 3. Now, how in the world do I figure out the answer to this using these numbers right here? Well, that's why I used a simple one, so it's easy for you guys to see. So what you could have done is you could have said, oh, all we have to do is just do 5 minus 3. So in this case, what you're going to do is whatever number links with 5, which is the 9/12, 9/10, and then you're going to subtract the 1/5. It's so much easier if you're just putting in easy numbers for you to understand what to do. So you need to change these to common denominator, which would, I could change these to tenths. So times this by 2 and by 2. So now it is 9/10 minus 2/10. So 9 minus 2 is 7/10. So your answer would have been 7/10 there. Here, again, I'm just going to use an easy problem here. This is going to be a 3 plus blank equals 5 now. Now, how would I solve for this number right here? Well, in this case, I would have to do the opposite, which is 5 minus 3 will give me my blank. So in this case, I got to do that, whatever that 5 is linked to, which is the half minus 5/12. So I'm just substituting in numbers, so it's easier for my brain to understand what's being asked here. So you have to come up with a common denominator, which if you did that, you would have saw that you could have changed these to 12ths. So 5/12 is already into 12ths. So then this one could times by 6, so that would have been 6/12 minus 5/12. So 6 minus 5 is 1/12. Your answer is 1/12. All right, next. Sarah is making a keychain using bead design shown. What fraction of the beads in her design are either a blue or a red? So in order to figure this out, the fraction means the bottom number is how many total there are. So how many total are there? So it is a 1, 2, 3, 4, 5. So we're going by fives 3 times. So 5, here's another 5, so that's 5, 10. And then here is another 5, so that is 15. So that means there are 15 total beads here, but they want to know which ones are blue or red. So we're going to be counting the ones that are blue and red only. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So therefore 11/15 are either blue or red. Next question says, in making the keychain, Sarah uses the pattern of the beads 3 times. After the keychain is complete, what fraction of the beads of the keychains are either white or blue? So now we're going to still do the same thing. How much are there total here? There is only 15. But now we're only going to worry about the ones that are white or blue. So we're counting only the white and blue ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore 9/15 are that. So this would have been okay for me to answer that as an answer. But then it said we're going to times it by 3. So therefore we have to times both the top and the bottom by 3. And if you did that, just to save time, it would have been 27 over 45, which is still equivalent to this. So that would have been a thing for you to write there. Next, it says Tom has 7/8 a cup of olive oil, and then he used a half a cup to make salad dressing, and then 1/4 to make tomato sauce. So how much olive oil does he have left? So in order to figure this out, first it's saying this is all he has. And then it said he uses, so that means you're going to subtract off a half. But that was not all that he used. He actually used more than that. He used another 1/4. So to make this a little easier, what we should do is we should just probably add up everything that he used and then just subtract it once. But the thing is here is that all the denominators are not the same. So what I should do is find a common denominator that could be used. So if you look at the largest one, which is an 8, can I get a 2 to an 8? You should be saying yes. And can I get a 4 to an 8? And that is also a yes. So therefore, we just found a common denominator. We're going to change these to 8s. So I'm going to add these first, times this by 4 and this one by 4. That would have been 4 8s plus. How do I get a 4 to an 8? I times it by 2 and by 2. That would be 2 8s. So once you add that, comes out to be 6 8s for this part. But now we're supposed to subtract away from what he had. So what is 7 minus 6 is 1/8. Because they both have the same denominator, we are done. It was 1/8 cup. All right. So next, this one said on Friday, 1/6 of the band practice was spent trying on uniforms. The band spent 1/4 of the practice marching. The remaining practice time was spent playing music. What fraction of practice time was spent playing music? All right, so it's saying one whole practice. And then what happened was they subtracted off 1/6 was spent trying on uniforms. And then they also used up another 1/4 on marching. So what they wanted you to do first is see how much they used up on marching and uniforms, and then subtract off the remainder from the whole practice. So what we should do here is we should find a common denominator. The common denominator, we would be going by 6. Can I get a 4 to a 6? No, so I'm going to go up 1 by 6 and 12. Can I get a 4 to a 12? And this is where I can. So I'm going to change these to 12s by timesing this one by 2 and this one by 2. That would be 2 12s. And then this one, timesing it by 3 and by 3, that would be 3 12s. So when I add that, that comes out to be 5 12s of the time was spent on doing other things than playing music. So, but it says, now I'm going to subtract off 1 whole minus my 5 12s. The issue is with this is that this is saying 1 whole. How can I change it so it still has the same denominator of 12, but still means 1 whole? So if you remember, if I want it still to be 1 whole, I would just do 12 over 12, because how many 12s go into 12? That is still 1. So now this is just another way to say 1 whole. It's just in fraction form. So what is 12 minus 5 is 7 over 12. So 7 12ths was spent practicing the music. Now this one says Mr. Barber used 7/8 of yard wire to put up a ceiling fan, and then he used 1/3 of the yard wire to fix a switch. So first they want you to find a common denominator, and then it says how much wire did he use to put up the ceiling fan and to fix the switch. So combined. So therefore we're supposed to be adding this. So to find a common denominator here, 7/9 and then 1/3. So first off, what I could have done here is looked at my bigger one, which is a 9. Can I get a 3 to a 9? I sure can. So therefore, I could have kept them the same by multiplying by 1, which would still give me 7/9. Here, what could I do to a 3 to get it to a 9? I would have timesed it by 3 and this one by 3. So 3 times 1 would have been 3. So therefore, when you subtract this now, add it, because this was an adding problem. We should have added to see how much he used in wire altogether for the ceiling fan and the switch. So when you do that, it would have been 10/9, which is a mixed number, which we could not have as an answer. So therefore, we should divide this out. How many 9s go into 10? That would be 1. When you subtract, that would be a 1. So therefore, my answer would have been 1 and 1/9. Okay, next over here, I will do some of these with you. This one, I should, again, make sure you find a common denominator. All right, don't worry about writing it in simplest form. So here we go. Here, look at your biggest one, which is a 10. Can I get a 2 to a 10? I sure can. So therefore, I am going to change these to tenths. Since this one is already in tenths, that remains the same. Here, what would I do to a 2 to get it to 10? I times it by 5, and I times this one by 5. So 5 times 1 is 5. So now I can go ahead and subtract because my denominators are the same. The only thing that changes is the top. So 7 minus 5 is 2. So this would have been 2/10, and keep it like that. Yes, you could have reduced it down by dividing both top and the bottom by 2, but I said you don't need to do that. So how many 2s go into 2 would be 1, and how many 2s go into 10? That would be 5. So one or the other I would have accepted. Really, I only want you to do this. Don't worry about reducing this year. It's not necessary. So you will have 3 for homework, 4, 5, and 6. I am going to do a couple with you. So here it is. Number 7. If I wanted to find a common denominator here, here I could have gone by 7s, or I could have just done the quick method of just multiplying these two together, which if you do 7 times 4, that would be 28. So I'm going to change these to 28s. 7 times what will give you 28? Be timesing it by 4, and this one by 4. So 5 times 4 is 20. And then here, what do you do to a 4 to get it to 28? You times it by 7, so you times this one by 7. 7 times 1 is 7. 20 minus 7 is 13 over 28. And that is your answer for that one. Next, again, you could have just done the quick method to do this. So I'll just do that again. Quick method would just be multiplying these two. 8 times 3 is 24. So I'm just going to change these to 24ths. 8, how do you get an 8 to 24? You times it by 3 and this one by 3. 7 times 3 is 21. Plus, now remember they're adding now. What do you do to a 3 to get it to 24? You times it by 8 and this one by 8. So then when you add, now I can add because all the denominators are the same. 21 plus 8 is 29. Now, this one is a big head, as they call it, which means it is improper. So we cannot keep it like that. So we're going to change it to a mixed number. How many 24s go into 29? That would be once. This would be 24. Subtract, that would be 5 remaining. So therefore, my mixed number here is a 1. And then the fraction would be 5 over 24. And that is your answer for that. Here we go, next one. And I can, again, do the quick method as well of just multiplying these two together, which is 30. So I'm going to change these all to 30ths. So how do I get a 6 to a 30? I would just do the opposite of multiplying that, 6 times 5. So I'm going to times by 5 on this side. So 5 times 5 is 25. I am adding. And then what do I do to a 5 to get it to 30? times it by 6, and this one by 6. 6 times 2 is 12. So now I can go ahead and go across. 25 plus 12 would be 7. That would be 37 over 30. So again, this is considered an improper fraction or a big head, which we cannot have. So now I got to divide that out. How many 30s go into 37? That would be 1s. That would be 30, subtract, that would be a 7. So my mixed number would be a 1 and 7 over 30. So 1 and 7 over 30. Okay, next one. You are not going to do 12. You will do 11 though. We're going to do 10 though. Kayla mixed 2 liquids for science experiment. One container held 7/8 of a cup and the other one held 9/10 of a cup. What is the total mixture, total amount of the mixture? So there, here, they want to know the total amount. So one cup had 7/8 and the other one had 9/10. Okay, now we could sit here and multiply these. It's just going to be a big number. It's going to be 80. So that means these numbers are going to be pretty large too. So I could go that route, or I could just go by multiples of 10. So 10, can I get an 8 to a 10? No, I cannot. So next multiple of 10 would be 20. Can I get an 8 to a 20? Again, no. How about into 30? No. How about an 8 into 40? And this is a yes. So I can change all of these to 40ths. All right, so I got to times this one by 5 and this one by 5. That would be 35 40ths plus, then times this one by 4 and this one by 4. So that would be 36. So this one is actually a big number all by itself. So when you add this, it comes up to be 71 over 40, which is huge. But again, that means it is improper, which we cannot have. So down here, I'm going to divide this out. How many 40s can go into 7? It can't. How about into 71? Only once. When you subtract, 1 minus 0 is 1. 7 minus 4 is 3. Is it smaller? It sure is. So therefore, this is my mixed number. It is 1 whole. And then 31 over 40. Cup. So 1 and 31 over 40th of a cup. All right. So that is that side of the homework. And then the back you will just have 1, 2, 3, 4, and 6. You can cross out 5, and that is what you have to do on the back. And you are done with 6.5. I will see you guys later. Bye.